something at my in-service. You know those days when you guys are going to, you have days off, we have to work, okay? Well, what I learned is there's a way to remember, there's another way, I guess it's pretty much, everyone knows this except I didn't know it. If you have the, why isn't that drawing? If you have an XY axis, or not a, let's just call this unit circle, even though that doesn't look like it's a circle. But in quadrant 1, remember that all of your trig functions are positive. In quadrant 2, which one's positive? Just sine, okay? So if you remember these, and over here, just tangent and cotangent are positive. And over here, just cosine is positive. So one way to remember that is you remember this acronym. All students take calculus, okay? And so that what that means is that all of your trig functions are positive in the first quadrant. Just sine and its reciprocal cosecant are positive in the second quadrant. Tangent and its reciprocal cotangent are positive here. And cosine and its reciprocal secant are positive there. And everything else is negative. Okay, so that's something that you can remember. I just thought I'd throw that in because I learned that. I learned a new trick too for using your fingers to figure out the unit circle, but there's a video on it. I'll show it to you sometime. It's kind of cool. But you put down your third finger, and that's there for 45 degrees, and you get like root of 2 over 2. It's kind of cool, and that's cosine, and sine is root of 2 over. I'll show you that. Okay.
Number 1, 2, 3, and 3, 0.
Yeah. So let's get rid of this chunk that I put down here. So this has to do with 3 other inverse trig functions that we're going to talk about. So the first one being secant, okay? And you look for the answers for secant just the same places as you look, inverse secant, the same places you look for inverse cosine. And that's in quadrants 1 and 2. That's what this means here, okay? And you can't, and the x, the values that you can plug in for inverse secant have to be bigger than 1 or less than -1. And that's because if you remember the graph of secant, right? If I graph secant, it kind of does like, what does secant look like? It's cosine, and it kind of looks like this and like this with these asymptotes. And it never gets less than 1, and it never gets, it's always less than -1. Okay, so the domain for inverse secant has to be bigger than 1 or less than -1. Okay, that's what that means. Okay, and you look for the answers for inverse secant in quadrants 1 and 2. And we'll try to find a clever way to remember these. But inverse secant and cosine go together, right? So you look for them in the same quadrants. Okay, inverse cosecant, you look for the same place as you look for inverse sine, and that would be -pi/2 to pi/2, or in quadrants 1 and 4. Okay, so that's where I'm looking for the answers to this problem. And again, I have to plug in numbers bigger than 1 or less than -1. That's what this means. Okay. Now the weird one is inverse cotangent, and inverse cotangent, for reasons beyond our control, it's due to the graph of cotangent. But inverse cotangent you look for in quadrants 1 and 2. So even though inverse tangent is found in quadrants 1 and 4, inverse cotangent is found in quadrants 1 and 2. So that's kind of an exception to the rule. So here it's the same as its reciprocal. Here it's the same as its reciprocal. But here, inverse tangent is found in quadrants 1 and 4, but inverse cotangent is only found in quadrants 1 and 2. And I'll show you the way that works in a minute. Okay? And then we're just going to do a bunch of these problems. Okay? So this one right here, and these have to do a lot with the domain of these, domain and range of these straight line. So, and I like to kind of draw pictures of these as I go because it helps you think about that. Sine of 5 pi over 4. Where is 5 pi over 4? Which quadrant? Jason, which quadrant is this 5 pi over 4 in? That's right, it's in the third quadrant. Okay? So you draw a picture right there in the third quadrant. And then what you want is, but the problem with that is that inverse sine is only found in which two quadrants? 1 and 4, okay? 1 and 4. So what you need to do, so this says the sine of 5 pi over 4 is something. That happens to be, anyone know what the sine of 5 pi over 4 is? You should know that from your unit circle. Negative root of 2 over 2, okay? But that's not so important because what you're trying to do is find an angle. This says find the angle that has the same sign as 5 pi over 4, but you cannot be in the third quadrant. So which quadrant would I have to be in? In the fourth quadrant, because that's where inverse sine has its range of values. And so what would I call that angle right there? What's that angle? It's 45 degrees or negative something. Negative, not negative 45. Negative pi over 4. Okay? Negative 45 or negative pi over 4. You understand that? So even though, because the range of this function is different than the range of this function, okay? So, or the, let's see, the range of this function, you have to jump over here to get out, to find values that are okay for inverse sine, okay? So this one, which quadrant am I going to be in for this one? Sine of inverse tangent. Where is everything positive? Where is everything positive? I just showed you that. Quadrant. So if it's positive, you just have to draw the picture in the first quadrant. That's easy. Okay? And a tangent is opposite over adjacent, so I'm going to put 1 there and 2 there. And this one you have to do the Pythagorean theorem. What does this side come out to be? Root of 3. Root of 3? No. No. Root of 5, right? Root of 5, right? 2 squared plus 1 squared is equal to 5. And so then the inverse, the sine, so this says there's some angle here, right, whose tangent is 1/2. I don't want to find out what the angle is, I want to find out what the sine of that angle is. So what is the sine of that angle looking at this picture? 1, not 1. Opposite over hypotenuse. It's only 1 if this were 1 over here, right? That root of 5, okay? 1 over root of 5, which is equal to root of 5 over 5 when you're rational. Okay? So that's the way you do that one. So this one here, next one. Let's move on. These are fun. I love these ones. They're a little bit tricky. Got it? So let's put arrows on both ends of the graph since we're on the cutting edge of technology here at Monarch High School, the technology high school. Okay? And so now I'm going to take away my arrows. Here we go. So inverse sine is negative. Which quadrant am I in? Which quadrant am I in? Red? No, just in. Fourth quadrant. I'm down here. Because inverse sine is negative in the fourth quadrant. So when I draw this picture, I call this -1 and I call this 3. Is everyone okay with that? Okay, because sine is -1/3, so I always make the hypotenuse positive. So that's -1, that's 3. And then I do the Pythagorean theorem to find this side. What's this side? Root of 8, okay? But a better way to write root of 8 is 2 root of 2. Yay, 2 root of 2. All right, so then I want to know the cosine of this. So the cosine of this angle theta right here, well, the theta is actually the angle from here to here. But what is the cosine? Adjacent over hypotenuse, right, which is 2 rooted 2 over 3. See? Now, let's try this next one. So, which quadrant am I going to draw my picture in? Second, because inverse cosine is negative in the second quadrant. So I'm going to draw a picture here, like that. Call this side over here -1, right? Opposite over hypotenuse. Call this side 3. And I get root of 8 again, don't I? So this side over here is going to be 2 root of 2. So what is the tangent of this angle right here? That's your theta. 2 root of 2 over -1, which is just -2 root of 2. That wasn't a very good clue. Since this is going to be played to hundreds of thousands of people on my YouTube channel, I'm going to make that really easy here. Okay? -2 root of 2. Okay. So, what? What? Oh, you get an A. All right. So this one,
John Famous today in class.
okay. You don't even have to draw a picture because inverse cosecant of -1, it's positive. Well, let's draw a picture anyway. Right? But we're going to go up here to the first quadrant, and if cosecant is 2, that means that the hypotenuse over the opposite is 2. Understand that? And so this one is a little bit different because if cosecant inverse is 2, you can find this side which comes out to be root of 3. And basically here you're looking for the angle, right? It says what angle has a cosecant ratio of 2 over 1? Well, that's the same as the angle who has a sine ratio of what? 1 over 2. So looking at your unit circle, what angle has a sine of 1 over 2? What angle has a sine of 1 over 2? Pi over 6, yes, or 30 degrees, right? So the answer to this, they actually want an answer for an angle. So this one over here is pi over 6 or 30 degrees. Okay? So should we do this one too? Questions so far?
How did you know that
Because cosecant and sine are reciprocals of each other, right? So if cosecant is 2 over 1, then sine is 1 over 2. Okay, and so this says what angle has a sine of 1 over 2? And that angle from the unit circle is 1/2. Okay? Let's do another one. Let's do this one. Which quadrant am I going to be in? Where is secant negative? Same as cosine. Over here, right? So secant is hypotenuse. No? Secant is the reciprocal of cosine, right? So cosine and secant are both negative in quadrant 2. Doc? Now it's in that. Yeah, that's right. And so you call this side actually positive 2 root 3. And you call this side hypotenuse over adjacent, right? You call this negative 3. Follow me? Right? And then you can do the Pythagorean theorem, and 2 root of 3 squared. 2 root of 3 squared is 2 squared plus 3 squared, which is 12. Okay? And this squared is 9, so this side ends up being square root of 3. Okay? So the tangent of this angle right here is root of 3 over negative 3, or just negative root of 3 over 3. How many degrees is that? Anyone know? when is tangent negative root of 3 over 3? In the second quadrant. You don't have to know the angle, but it has to be 150 degrees. I think. That's right. Yes, ma'am. No. Cosine's negative. Inverse cosine and inverse secant are negative in the second quadrant. Okay? No, normal cosine is always positive in the fourth quadrant. X. Yeah, positive. Okay. I'll get through these. Okay? So for this one, if inverse secant is 3, that means that inverse cosine is what? You don't even have, this means inverse cosine is 1/3. So a lot of people don't do this right. You have to know that if inverse secant is 3, inverse cosine is the reciprocal of 3, right? Does that make sense? Because you can draw a picture if you want. So this is, secant is hypotenuse over adjacent, okay? And so cosine is adjacent over hypotenuse, right? So if I take the inverse cosine of 1/3, and I'm in radian mode on my calculator, I get out an answer. And that answer is, anyone have their calculator with them? That answer is 1.23 radians. 1.23 rads. You don't have to put rads there, but just to let you know I'm not in degrees. Okay? How would I do this one? Inverse sine of what? Negative 1/4. Okay? And if I do that on my calculator, I should get out a negative angle, because remember, inverse cosecant, like inverse sine, are found in the fourth quadrant, and except you have to go backwards from 0. And if I plug in my calculator, I get negative 0.253 radians. Got it? Negative 0.253. Question on that? So here we're finding angles. Okay? This says what angle has a sine ratio for it of negative 1/4, and it is negative 0.253 radians. So this one, which quadrant am I going to be in? Where is everything positive? First quadrant. So whenever it's positive, you just have to worry about the first quadrant. Right? So cotangent is adjacent over opposite. So tangent, you should take the inverse tangent of that and find 2. And do that on your calculator. You get that theta is about equal to how much? 1.1. That's is that correct? 1.1. Yes, Sam. You get about 1.11 rads. Okay. Now this one is a little bit tricky, so I'm going to give it its own special page. Okay. Partial. So inverse cotangent of negative 2. So the only one you really have to be careful of, everyone always gets these wrong on quizzes and tests, is when you have the inverse cotangent of a negative number. Okay? I'm going to show you how to deal with that right now. So this means what angle has a cotangent of negative 2? Where is inverse cotangent found? It's found in quadrant 2, right? So you want to draw your picture there. Yes? Okay? And so this means that this side over here is negative 2, and this side over here is 1. So how can I find out what this angle is? How can I find out what that angle is? What's your calculator doesn't have a cotangent button. It does have what kind of button? It has a tangent button, right? So I can take the inverse tangent of what? Negative 1/2. Now, here's where the problem comes, okay? Someone do inverse tangent of negative 1/2 for me on their calculator in radians. Negative 0.46. But negative 0.46 is not in the second quadrant, it's over here in the fourth quadrant, right? Because inverse tangent is only found in the first and the fourth quadrant, okay? And so what I have is an angle that has the same tangent as this angle, but it's down here. So how can I figure out what this angle from here to here is? What would I have to add to that angle? Very good. Because what that's giving me when I do that, that's giving me that this angle is 0.46, right? So if I added, it's negative 0.46. So if I added pi to it, right, I would get this angle from here to here. So I'm going to go negative 0.46 plus pi, which is 3.14 about, right? And I get what I get. What is that? Positive 2.68? Probably it is. 2.68 rads, okay, from here to here. The other way I can do this, okay, is since I know I'm in this quadrant, if I draw this picture, I can do the Pythagorean theorem and find that this side is what? Root of something. Root of 5, okay? And if I take the inverse cosine of negative 2 over root of 5, I should get out exactly the same angle because inverse cosine is also found in the, when it's negative, it's also found in the second quadrant. So I can either do this by taking the inverse tangent of the reciprocal and adding pi to it, or I can draw the triangle and find this side and then take the inverse cosine, okay, and find out that angle from here to here. Okay, so two different ways to do the same thing. All right, so I think that's all she wrote. Your homework is right there, and that's all, folks.